Okay, let's continue here. Standard is not a member of the layout of the basic type layout. Why not? Oh, right. I was going to use X layout type. Standard on every layout. Standard's not a member of. X layout type. See if I have that more often. X layout should have it. Well, that's that's a different one, I think. Those are just namespaces. Array elements also using X layout type already. Or did I just add it? Or did I just add it? Well, let's compile it again. In instantiation of struct, required from here. Static assertion failed. Required alignment equals 4. Yeah, because I fixed that. That is no longer the case. This is this should have been 16, and now I fix it. So now it is 16. And the enforced alignment will also be 16 now. Diddly-doo-doo. 32 compilers are running. And they're finishing out of order, or I mean, not at the same time. Static assertion failed. Yep, also correct, because also this was fixed. This is now 16. Okay, boomer. (16 equals 12). Ouch. Yeah, I'm getting... No, wait. Struct layout members tuple offset is wrong. It should have been 16. Damn it. Why? The correlation type of and then members tuple. Right, and then the offset. Hello, peoples. I want to see this type. We need better error reporting for compile time stuff, like const expressions. It's hard to debug this. How can I get it to print this type? Let's make a template. Test. Struct test. Can I make it a function? That will be easier. Let's try make it a function. Size type test T. Expression. Let's move this static assert inside here. Although no, it's not depending on T. Well, we can make it depend on T, because T is going to be the top position. Well, might as well do this one. Oop. And then I need to call test. No, it's what a nonsense. Top is not top position. Let's start with calling test somewhere. Can I just do static assert here? No, that's maybe it. Let's make a static function. Which calls test. Passing this type. No, I just want to test. Which type did I want to see? This one, the layout. Not sure we can construct a thing, but let's make a default default constructed parser to test, and that's equal to t. And then I can make this again a t. It's a bit of a hackish stuff, but let's see if I can now finally. Argument declaration type must be in expression. Declaration type. Oh, let's see. Yeah, excuse me more. That's no longer a declaration type. I think that struct layout is actually a no. I'm just going to do declaration type E because the original has declaration type. But that's equal to T, of course. But well, I don't know. I just want to see the type, man. Show me the type. Expected a type called declaration type. Yo, you mean a memory tuple. Okay, so VI. What it has a problem with member tuple. Expected a type. Tuple elements. Did offset members tuple. Oh, looks like a type, yeah. XLE, well, I'll answer you then, man. You don't get what I'm trying to do. Well, I am trying to write a Vulcan engine, which you can Google, of course. I mean, I'm assuming Google knows everything. Vulcan engine. What is a Vulcan engine? Okay, this is on the webpage www.vulkan.org. Does it work? Mention engine. Seems quite limited. Control F engine. Compute engine. Nope. Maybe I should put it between quotes. Of course, if you look at www.vulkan.org, you should figure out what Vulkan is. There's another Vulkan game engine. But yeah, that's GitHub, so that you just get the description of someone else, maybe. Quake 2 Vulkan, oh, awesome. Well, this is really a game engine, so I guess that's clear. And then it's using Vulkan as a backend instead of, say, OpenGL. Vulkan is the successor of Vulkan is the successor of OpenGL. So OpenGL is from, I don't know, it's very old. And new video cards came out. I mean, really, really a lot of newer and newer and newer and newer and newer and newer. And by now, the API of OpenGL just is not suitable anymore for the modern GPUs. So the drivers that have to write for it have to do all kinds of guessing and all kinds of hard and inefficient work to match the OpenGL API to what the hardware is really doing underneath. So the same group that designed OpenGL, the Kronos group, that exists of every respectable company involved with graphics. and they designed a new API, and they called it I thought it, I'm not sure anymore. It was, I think, a magma thing, and that didn't work. Didn't come off the ground, so at some point they did it again, and then they called it Vulcan, as in the magma breaking through, and that did take off. And now it's a new API for the modern GPUs. And the result is that you can really access the bare metal of the GPU, which, if you do it in the right way, indeed gives you a much more efficient code and therefore a higher frame rate. A much higher frame rate in some cases. But what I am doing is, Vulkan is such low level, you can control every little detail of your graphics card. You have to specify everything. The driver is not doing anything anymore for you. So it's kind of the opposite of OpenGL. And means that you need 1,000 lines of code at least, maybe even more, to just get a single triangle on your screen. And in the end, code that uses a Vulcan API is just super verbose, super large, and completely impossible for me to remember, because my memory is pretty bad. So what I wanted to do is write a layer in between the Vulcan API and my program, and that takes away the need for me to remember the whole Vulcan spec. So this is OpenGL. You use the Vulcan spec. So you start at well, I mean, it's really a lot. I never even read this completely, because it's so much. Basically, you have to remember all of this. And now note, I've been scrolling a while, right? Okay, so the scroll bar is now here, at the top. And it goes all the way down to the bottom. So yeah, it's so much you cannot even read it once. So I'm trying to build an expert system that takes as input simple things, like I want to draw a triangle, aka like OpenGL, but then does all the hard work for you. So it's a Vulkan expert system or Vulkan engine, I don't know, one of the two. I think my thing is more than just a Vulkan engine, in that I really design my own API to work with it. So in the end, I hardly have to do any more with, I think that's the goal, with the Vulkan API, which is just way too complex. Now you might argue, well then it will become as slow as OpenGL, but no, that's not true, because OpenGL was a fixed API. And I have 100% freedom to choose whatever I want. And I'm basing it on my own libraries that I wrote in the past 10 to 20 years. Especially the last 10 years, where I have dedicated myself to writing a fundament for C++ applications that is aimed at parallelization. So using all the threads that you have. So I have a really good basis to write threaded applications. which I only more or less recently, which I recently, let's say 2 years ago, more or less finished. That's how I should say it. So, having now finally my own base for heavy-duty, super complex, very multi-threaded C++ applications, I started to use it to write my Vulkan engine. And what I can do with that is make things that are extremely complex, but not for the user. So the user of the Vulkan engine should get an API that is rather easy to use. Easy between quotes, never easy. But the results should be as fast as you can get with Vulkan. I mean, my engine is written in a way that it's, I hope, using gets the maximum out of what you can get out of it. Okay, I hope that answered it. Well, there's just a warning we have here. A static assertion failed. Offset X is wrong. That is my assertion. And now we can see the type, namely in instantiation of size type T with T equals, and then we see it, what it is, namely struct layout. Oh, that's a struct layout. What? Oh yeah, no, of course. Yeah, it's exactly struct layout. So it is a struct layout of the standard tuple, member layout, top position, basic type. Comma, shader builder, top position, another basic type, another float. And then we get float 2, top position, basic type. It's float 3, and now we get then the thing that we will use. And that is a Vulkan shader builder member layout. Top position, array layout of basic type float with the size of 32. Right. Gonna fix this as well. This thing returns a size type. Yeah, well, let's not return anything. And here we have expected. Struct layout is a const expression of what type. It's a type returned by make struct layout, which returns a struct layout. But okay, so it's not a type, it's a thing, an object. So we get the tuple element number 3 of the tuple that is of the type that we just saw, the members tuple. So if I change this, this is of course just T. And then we get the same thing. And it prints what T is here. But really we are only interested in a members tuple. So what I also can do is then not pass, I just can make this a declaration type, which it was in the first place. So now it's a type, and then I can pass that by constructing it again. I think this works as well. Or not. What's the error here? No matching function for call to. I cannot default construct that type. Well, we can also pass it as a template parameter directly. So it's not going to use E. I'm not even using E here, I just use T. So instead of passing the declaration type is okay, but we just don't default construct it. We pass it directly as the template argument, yeah, to test. So now we just set T to the declaration type of the thing. Now I still have the same. It should compile again. No matching function for call to test. I'm an idiot. Or am an idiot. This test takes a T. Yeah, that's not really necessary, of course. I can just do it like that. We'll get there eventually. Okay, now we get offset of x is wrong, static assert again, and it prints a type, but that was a bit too large. What I really want is pass the members tuple of T. So instead of T, I'm passing now the members tuple of T. And then T becomes the members tuple. So now I can just remove the members tuple here, and then we still have the same thing, right? But now it's printing just the members tuple, which is still too big, by the way, but okay. I'm doing it slowly, kind of in the hope that people can follow it more, but see, so now it says T equals, and then you get the whole tuple, standard tuple, and then you get a load of types. So the first type is this, where it goes all the way to here. That's the first type, and then the tuple exists of multiple types. So we get the next type and goes up to here, and then the next type goes up to here, and then the final type goes up to here, I guess. Now really we only need the last type, because that's what we are passing. So and we do take this tuple element number 3, so that's the last type of the tuple. And then of that I look at the offset. So you can see in the last type, this was the last type. we take the offset, and the type is a member layout. Member layout, top position, and then internally it has array layout, because it is an array. Lots of other stuff. Interesting. Okay, let's copy this. And I have the actual type there. Go here again. So we have that the tuple element number 3 of t is equal to this. And then the offset is 12, but it should have been 16. Well, the type is member layout. Let's format it a little bit. So the template arguments start here. Let's use 4. And it has 2 arguments, top position, and then, no, it has a lot more. Array layout, basic layout. Let's put every template argument on a different line. Except this. That's just a string, so I'll leave that the way it is. Okay, so this is the type that we have. So it is a member layout with 2 arguments, top position and array layout. And if we look at member layout has an offset, and it is set to the offset of, just the template parameter offset, which is that one, which is strange, I think. It's not really strange, but member layout. Slightly confusing here. Confused as a more member layouts or what? Nope, I think this is all. One, two, three, four, 5. What did I do wrong? Oh, I've got an indentation. These belong to... so it has more than 2. It has 1, 2, 3, 4, 5. So this 12 is the offset. That is the template parameter of the member layout. Now the member is an array, and the array element has an alignment of 16. Therefore, this 12 is incorrect. It should be 16. How can we figure out that it should be 16? Where does this 12 come from? I'm afraid that this member layout is being constructed in a metaprogramming engine. So I have to do deep dive into that. Let's see, it should be the result of a call to a const expression function called array alignment, with as input the standard and the alignment. I don't see the alignment, so the 12. But and the reason that it needs to do that is because this is an array layout. The horror of it all. Yeah, okay. So wasn't it like there was a make member, or there was a make function somewhere? We just saw it. Let me see if I can find this back. Okay. Bad memory. The top position. That's where I am. Okay, this is what the user writes. So in terms of simple, right? The user has to write this. Well, not this line, but just use layout here and member here. And they look the same, except that here you have to number 0, 1, 2, and 3. The 3 now ends up there if you expand the macro. And under the hood, then we have complex magic. So it's calling make struct layout. I think that was the one. Okay, there we are here. This returns a struct layout that exists of whatever make layouts implementation returns, which takes the first tuple, which is equal to the first memo layout, and then the rest. And the first memo layout equals memo layout containing class first type, and then 0 for the index because this is the first member. And then we get alignment, offset. Okay, I agree with the offset. Offset is for the first member is always 0. What was I looking for? Alignment. Yeah. So we're not talking about offset, we're talking about alignment. So this alignment here is dubious because it should depend on whether or not I think that first type here. Yeah, well, first type is the first member. First member is the first argument. I don't know what that type is again, but to get the layout type of the first member, and then the rest is probably the same. So we go to the make layouts implementation. that calls compute max alignment. Okay, that it's a what is it? Cumulates. Is that the right word? Of the it cumulates the alignment. So it just the previous alignment, and if the next alignment is larger, then we use that. So we have the previous layout, max alignment, and the current alignment, and then we take the maximum of that. The current alignment is then struct member alignment, and struct member is the second template parameter of compute alignment. Till that is first unprocessed, which is the next template argument passed to make layouts implementation. Which is simply the template arguments passed to make struct layout. So again, all these template parameters are being passed as res members, then they are being picked up as first unprocessed. Which is then passed to compute max alignment. And then we use alignment on that. So we call eventually the alignment for each member should be part of the template arguments passed to make struct layout. And strangely enough, that's not the case for the first one. You would say you can just do first type alignment here then. First member alignment. I have the feeling that if it compiles it should work, and I think it's a bit too confusing to have two types. So I'm going to try to replace this with first member. In that case we just use alignment, the alignment member of each of the template parameters, because that's what this thing also does. Let's check that again. Yeah, it's confusing as hell. Let's try this. Probably need a type name there though. It worked. It's alignment is not a type name, so it's nonsense. Okay, so let's go with this for now, and then I'm going to assume that the alignment that is being returned is the alignment of each of the template arguments of that is passed to make struct layout, which was this call. So then make struct layout simply has the template arguments of make struct layout are the types of its arguments. In other words, the type of these macros, and then alignment of that, double colon alignment. And this is a macro that is defined as this. So these are struct member. So we call alignment on struct member. And struct member is using alignment by getting the alignment of the layouts that worked on X layout, which is the second template argument passed to the struct member. Okay, let me think. Layout working X layout. So the question is, what is X layout then, I guess? So X layout is the second template parameter passed to struct member. Which is the member type. Ah, okay. Therefore, the member type, if it is an array, is a C type array, which means that we're going to use this one. And then the alignment thereof is this. So this should change to array alignment of the standard, which you don't have here. So the standard, whatever, and the alignment, right? How do I get the standard here then? I guess X layout has a standard. Or I can wrap it in. Yeah, X layout has a standard. So X layout standard. So in the end, it's just a one-liner. Isn't it funny? At least I think this is correct, so let's try it out. Not sure if it compiles already, but that's the place where we specified alignment of an array member, so yeah. Zig Fu, yeah, kind of is, except I'm not being paid for it, but this is what I do 7 days a week. It's more than a job. What do you know? It compiles, and we have no assertion anymore. So it's fixed. Da 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 da. Awesomeness. Let me have a look at the git diff, because I added a lot of assertions. First I'm going to get rid of the assertions, I think. All of this is not interesting. So I added support for array alignment. This is the work of yesterday, or I determined what the formula was. And then we implemented. Well, this is still the test application. Here it is implemented. What we measured, with measurement meaning brute force GLSL compilations. And then we have change a few things from what it was layout to calling that new function. These asserts can also be removed. Methinks. Okay, let's, instead of deleting the assertions right away, and just commit whatever is not an assertion. Okay, commit this. That's big. What is this? I don't want to commit this. And I don't want to commit this. So I'm going to do split. And then this is partially correct. I'm going to edit it. And then instead of committing this line, I'm going to commit this line, which takes a 3 then. So that's equal to this line. Yeah, okay, well. And then the rest, yeah, there was this static assert. And I want to replace that with, I want to keep it, but I cannot say no because this has a 2 here. That should be a 3 now. I think for the rest it's correct. Position, yeah. Okay, I want to keep this as well. I'm just going to edit it, I guess. Edit it. So I want to delete this line and then add back. I want this line to be added back before it. And then add back the same line but with the 3 here. We don't want this test. I already moved that to the top, and we don't have this. Yep, let's commit this and this, and this is just debug output. That's okay. Everything is okay in this file, really. Let's go over it anyway. You know, the way I'm reading this is still based on my memory. I have a bad recall, but it's like remembering faces, you know? Yeah. No, not really. Maybe it is. Let's say you see a face and you know you already knew that you have seen that person, but you cannot remember the name. Or, but in this case, that's why I said no, it's not really the same. If you are given the name, then you cannot recall the face. So what happens is I have a bad memory, but when I see the diff, I remember that I changed it. So I'm looking at it, and my subconscious processes it and tells me, oh, that was something that was, you know, correct or working. I finished this, that feeling. So I do not read it, I just recognize it. And I say, yes, this is the hunk that I want. Okay, so this is the new function that I'm already using is here on there, and there's a fix for the README. And this is what I did today. I'm not sure about the correctness of moving this to basic type layout, but I think it's correct. I'm not sure in this case, but again, this could be removed, and here we have the fix, and here we have a change. Yeah, let's add that change. So add it, actually make the change, meaning that I'm just deleting whatever it was. I think the previous thing is exactly the same, but this is what the implementation does for the second and third, etc. member. It seems more logical to do that. I have a few asserts here. Well, let's not commit it. It's too specific. And this is the second fix. So I had already fixed it before the last one, of course. Okay, so that was all. Then shall I go over it again? I think it worked right. So this is what I just added. I added a few things, so I want to go over it again to see if it really looks okay. Okay, now I can commit it. I'm getting lazy. I always type work in progress. And now I have so many work in progresses that I feel like if I start adding real commit messages now, it's going to make no difference. Suddenly between all the whips I have an actual comment. Yeah. Was it specific what I did? Yeah, it was. I'm going to add a real comment. So this is fix array alignment for std 140. Then we have a div left, which maybe I can remove. So yes, I want to get rid of this one. This is no changes that I don't want. Just going to remove it. Yeah, no, actually I want to still do more tests, so I don't want to remove everything. So we are running now git restore -p instead of add. And I'm going to say yes on what I really want to get rid of. So it's split again. So yes, I don't want to get rid of this. And here we have the food. This is also goodbye. Then we have here, yeah, that is the undo of the remove of the comment. So I want to get rid of that as well, but I want to keep this. So now I have just those asserts left. Now I can recompile it. Well, it's pretty amazing. 75 viewers. Well, normally I am in the evening, my evening. So I'm in Europe. And then it hangs around 40 viewers, usually. Well, at the peak even. Now we're at 80. Seems, I mean, it should not be the same viewers, right? What date is it? Friday, right? Yeah. People are working, I don't know. So either these are all new viewers or they came watching anyway because of the notification and suddenly in the morning instead of in the evening. I don't know. It's probably, what is it? In the USA, it's now a lot of people come from the USA. Gabriel, okay, man. So you don't have to go to school. Or are you in America and now it's evening and normally you watch in the morning or whatever? Friday the 14th. Oh, my God. It could have been the 13th. It's a narrow escape. It compiled. I'm going to run it. It works. God knows why. Yeah, now let's do some real testing. Or continue the testing rather. Where's my top position? Here. So I added 3 floats to fake something with an why did I do this again? I needed something with a size of 12. So this of course has a size of 12. Oh yeah, I wanted to be 100% sure that I have just something that would normally put the next member at an offset of 12. So this is a float is a size of 4. If you get 4 plus 4 plus 4 is 12, and the next thing is, you know, is again a float. But for standard 140, probably 1.4, I don't know. The arrays is alignment is rounded up to 16. I figured out yesterday. So then this thing being an array is going to be put at an offset of 16 because the alignment must be 16. And that didn't work. It put the array at this array, x is an array of this size, and I put it at offset 12 in this struct. Because it didn't know that arrays should be aligned at least 16. And now I fixed it, so now it works. But what I really wanted to test is using a vec3. A vec3 under this standard has a size of 12 also, but an alignment of 16. However, because it is the first element, that does not make any difference whatsoever, of course. And we need to keep these 3 the same, these 2 the same. This is the layout declaration, and this is the C++ struct declaration. Now, then the alignment is still 16, obviously. I should delete this as one as well. I'm just getting the offset that my machinery is calculating with something quite difficult. But at the very least, this tests if the type returned by member is correct. Because this macro member tries to make sure that my struct members. Struct declaration is obviously just struct declaration. Yeah, it's just struct class name and then a base class. It's really minimal. The class name is what we have here. So it's just struct top position and then a base class. Now the macro member must make sure that each member in the struct is aligned correctly. So it has the correct offset and alignment. And it does that by using this as type for each member. And then that type forces the correct alignment and offset, but it acts the same as this type. So I won't know the difference, but the offset becomes correct. And in order to test if a line in a resize works correctly, I'm adding this static assert here. Because this is the canonical value that it should be. And this is the actual offset that X gets in this struct. So they should, of course, be the same. Now, the reason that I know what the canonical offset should be, given the current standard, is gotten from here, right? So this defines that. Okay, so, but okay, also the calculation could go wrong, so therefore I also added a static assert to test that it is 16. So now I'm testing both. I'm testing that this is correctly 16, and I'm testing that this matches that one. And this can be removed as soon as I'm sure that this whole calculation thing is going correct. Anyway, this should just work like before, like with the 3 floats. I've not done CUDA, no. I have it installed, but not coded with it. And the static assertion fails. Oh, no, doesn't fail. These asserts can be removed as well, I think. This was more for debugging a problem here. The reason that it fails now is while I was using floats, then the size is 4, and I skipped this test. But the vec3 has a size of 12. So therefore this fails for the vec3. I'm just going to remove it. Hello. You sent a comment in Japan. You mean in Japanese? I didn't see Japanese comments. I cannot read Japanese, so also that. Yeah, it compiles. No assertions. Obviously, it still works. And on to the next step, I guess. Going to remove this as well. I now believe in my code. Okay, so the next step is... Yeah, I know that Japanese. Konnichiwa. I wish I knew Japanese. C++, of course. It's They both start with a C, but that's a marketing trick of Microsoft. It's not related. C# is more like Java, I think. It was a replacement of Java, wasn't it? Okay, so what we really wanted, like 2 days ago, is make something that fails. And well, I described it in the description. There is a problem with this approach that I'm using so far, because C++ demands that the alignment is always a multiple, the size is a multiple of the alignment. And a vec3 in GLSL has a size of 12 and an alignment of 16. So that's not compatible with C++. The only way to get the size of 12 is by decreasing the alignment from 16 to 4. So 4 divides 12. But then the alignment is not correct anymore. So if I change this and I put the vec3 here, I'm going to need to change this. I'll just make a float. Well, actually, sorry. It's a big change. Let me call this as float unused 1. And then here I'm going to use a vec3, which I call v. So the alignment of this thing should be 16, but there is no way we can tell C++ to do that unless I would make the size also 16. Which would work in this case, but not if I add another member behind it. So if I add another float here, then that float should be just, hugging the vec3 at a distance of 12. The size must be 12, right? But if the size is 16, that wouldn't work if I add an element. So in order to get this thing have a size of 12, the C++ alignment must be at most 4. It's going to be 4. And if the alignment is 4, it's not going to put it at an offset of 16. It's going to put it at an offset of 4, because this float is 4. So this fails. Now, my formulas for calculating the offset work. They know how this works. So it's going to tell me that the offset should be 16. That means that this value here is going to be 16. But in reality, it's going to put x at an offset of 4. So this static assertion now should fail. Let me first use the same thing here. And well, not really the same thing. This must be member and start with 0. And my x has changed in a v. And I don't have an array anymore, so this is, I could delete this, but maybe I need it later. I'm going to add back an array or something. But I'll go ahead and try to fix my GLSL code as well, and other things. For a start, we don't have an x anymore. So this is now a v. And v is a vector, and in C++ I'm using an eigenvector. And let's just use the first element thereof. I think this should work. Or maybe it is just the first element is .x. I don't know. Let me just try .x. And in GLSL, I also don't know how Vec3 works in GLSL. So this is now v. I think there's also v.x, right? Yeah. This is a vec3 of a vec2. What is it? A vec2, but it's going to be the same thing. So I can just do .x, and then here this is a vec3, and just do .x. And I have another top position x here, which now also becomes v.x. Let me read what Mr. Fatman said. I started programming just now and started with C++. I have studied till basic structures of codes, if, else, for loop, etc. Okay. Write me a program that calculates factorial efficiently. And if you think that's too easy, then make it a program that calculates factorial of anything. So arbitrary large numbers. Writing a large number library is fun. So you can store the number is in an array. Let's say you make an array of unsigned long array, or the C++ way. It's maybe better. An array of unsigned long, and then you just store sequential digits in here. So in an unsigned long can, I know, take a few digits, maybe 10, I don't know. And then times 100, so you can store 1000 digits in it. But you have to make it work, because now you have split it up in many chunks. You wrap that in a class, etc. You know, if someone says editor looks horrible, that tells something about your brain, how you perceive it. And I think you make a big mistake if you then conclude that the thing itself is bad. It's just your perception of it. If you get used to it, if you just put time into it and learn it, then eventually you would end up with, you know, a better experience, a better method, and you would no longer think that it looks ugly. This is NeoVim, NVim. Why does it not compile? Top position has no member named V. Oh, that's funny. Did I not rename that then? V and V. I know, I'm good. But I made a mistake as well. So I'm also bad. Static assertion fails. Hey, what the fuck? Offset of V is wrong. Yeah, that was expected. So this goes wrong because what I explained, and we can fix that by manually adding a padding here for 4 bytes. Now the offset becomes 16 again. So the alignment of the thing is now 4, while it should have been 16. And by adding Oh, that's not going to work. I need to add 12 bytes. So now the offset was 4. After adding this, the offset becomes... Can you use a double? Double has an alignment of 8, I hope. So then this one gets an alignment of 16. Let's try this. Is that going to kill my computer? Yeah, not. Never used that before. Blah, blah, blah. Okay, the assertion did go away, so that's nice. We still have a problem here though. Eigen does not have an .x. It does have an x with as a function apparently. I'm gonna go for accessing the first float with square brackets. I think this should work, right? I'll be pretty silly if it didn't. Okay, so everything works using the vec3. But I had to add manually padding. And I don't want it. So now we get to the non-naive solution where this vec3 has to add padding in front of itself because the previous member isn't correct. It has to add padding to fix its misalignment, and we can do that if we know what the alignment maybe no. We just know we need to know the offset of the previous member. That's what we need. Yeah, so we are here. No, we need to know the offset and the size of the previous member. So at the moment we want to calculate, so this vec3, let me make an ASCII art drawing of the memory layout of this struct. So this is really a struct top position and then some base class, which I'm not typing here. And then we have a float unused as member 0, and then we have a vec3 as v, okay? And this in GLSL has an alignment, so the required alignment is 16. But the required size is 12. And you cannot do that in C++. So what we do instead, I'm starting to repeat myself, but I guess it's not that bad. So the alignment actually is going to be 4, and the size is still 12. Right? Because 4 must divide 12. Therefore, the offset of this thing is of course 0. So the offset is 0 and the size is 4 for the float. And the offset of this thing is normally 12, but we want it to be 16. Why? Because the required alignment is 16. Why isn't it 16? Because we could not tell C++ to make the alignment 16. So my trick is then that we want to add padding here, and I'm going to add the padding inside the vec3. So this padding is now going to be part of vec3, and just have a character padding, and then the size of the padding in bytes is equal to 16 minus 4. Well, it's slightly more complex because you also have to take the offset into account. What I really want is a user padding such that the you need to round up to a multiple of 16, the offset plus the size. So, and then again minus the size, I guess, yeah. What you really want is, yeah, I don't know, some formula, some formula of offset and size of the previous member. Okay, and this must be added to the vec3, or rather to whatever the type is of this vec3 here. And the type is align and resize. And align and resize looks like this. So in order to do that, we need the offset of the previous member. Static const expression size type. Offset previous member. And we also need size of the previous member. And then I can calculate, yeah, how would you call padding when it's not padding, but when it is something that comes before it, in front of it? Maybe it will be easier to add it to the padding of the previous member itself. So that means I would need to know the offset, the required offset of the next member. Then I don't even need a size. Is that easier or not? Then I need my own offset. I think it's easier to formulate in terms of the previous member. Yeah, even getting this to work is going to be a pain in the ass. So let me start with trying to get those values. That is not easy, I think. Layout. We just have T and layout. That is not enough, I think. I guess I can simply pass member index separately. Suppose I would have the layout of member index -1. Then I have the offset and the size. Pretty sure of that. This layout here is defined in the base class, so that's defined in this GLSL data. It's this. It is a layout of the standard tuple element of a given memory index. And every layout specifies an alignment and a size. It does not specify an offset. Ouch, I have to calculate it recursively what offset is. I don't want it. I already should have an offset. Here's an offset for the member layout. That's what I need. Member layout has an offset. Okay, so what I need is the offset in layout. Now I can, in this case, this is specialization of layout for member layout. I can just add it, of course. But I have multiple layouts. There's also a way to get it for the other specializations. There's a layout for an array layout. So the only way then to get the offset is when I get the offset from the array layout. And I have a layout well, I'm not looking for struct layout. It is going nowhere. Blip. Okay, we have a layout of basic type layout. There's no offset inside here. Dang. Maybe it's never going to happen that we have a layout of basic type layout in this case. I think we only have to do with member layouts. We start with member layouts. The basic type layout does not know an offset, and then the member layout wraps basic type layout and adds an offset. And array layout wraps member layouts, I guess. So then we still have an offset. So not all layouts will have an offset, but it should still compile. That would be my guess. It's easy enough to test, I guess. let's just begin with it. I'm going to add an offset. Let me add offset yeah, feels like the beginning is a nice place, right? So in this case, the X layout is the mem layout. Therefore, I can take the offset of that because mem layout has an offset. So now the specialization of layout for mem layout has an offset. Pretty sure I also need that for... I also need it for the array layout specialization. And then we also have to do X layout offset. Something went totally wrong here. And this we can only do when array layout has an offset. And it doesn't. It only has an element layout. That's an X layout. It could be a basic type layout. I'm not sure. I might not be able to add it to array layout in all cases. Let's try this. Yeah, this is nonsense. Element layout cannot have a... cannot have an offset. Okay, so this probably won't work, but let's try the element layout. See what that brings us. Not even sure what type element layout is. Element X layout. Maybe it's also only mem layout, and then it would work. So yeah. So if that worked, then now in the case of basic layout, we really don't have an offset. But maybe we'll have an offset for all the layouts that are being used where we need the offset. So hopefully now this layout always has an offset. which means that this layout has an offset, and that is then the layout of the data struct, which is the type of what? Oh, right, this is a template. It's a bit confusing, but this is a layout is not a type, it's a template type. So passing the member index to layout, and then when we can take the offset of that for each member. So I can test that by simply getting the offset of, I have the feeling that this cannot work. But let's see. So if align and resize, second template parameter of align and resize is now a layout of a given member index. If that has an offset, then we are in business. And it is not the previous member offset, but just to see if it compiles, right? If there is an offset at all here. Well, yeah, Mr. Fatman, did you do the big number as well? Can you calculate a factorial of 1000? It's not about finishing the task, it's about writing objects, writing classes. So you make a class big number. And that then should act like something that you can multiply with integers, maybe even multiply with it itself. And it's a wrapper around an array of unsigned longs, something like that. Static assertion failed. Well, it's better than saying that offset doesn't exist. Why the hell would that be for? Oh, because I don't have my padding yet. I guess I'll just comment it. Oops, comment out is assert for now because it's simply not working. Yeah, I mean, you become a good coder, Fatman, by measured by the time that you put in coding. Okay, so coding 5 minutes makes you 5 minutes better, and coding 2 hours makes you 2 hours better. It doesn't really matter how long it takes. get it to work. Extend it to infinity. If you don't think it's interesting enough, I have other things that are more interesting, but they're also a little bit more difficult. You have to start somewhere. I can say hello to you, yeah. But I cannot pronounce your name. Dai An Fung, I think. Okay, it compiled, so that means that apparently we have hope that, yeah, I don't know where I was. Top position, I guess. That would work. So the offset works in the sense that align and resize. Align and resize were your shader variable layouts. So now the layout has an offset, and if now instead of passing the layout here, I just pass separately the layout of everything and then the member index, then we should be a little bit closer now. So I'm going to change all the align and resize things. It's just one file. And I'm going to pass layout and member index separately. Int member index. Maybe call it different than layout. So now we have let me go back what the right name is for that thing. The right name is coming from whatever layout is, which was part of the base class, part of data. I'm calling it layout here. So okay, I'll just stick to layout. Yeah, it's not really, I don't know. I don't like using a capital L here. I have a feeling that it's just something else. I'm going to call it member layouts. Member layouts. It's all the layouts, right? I think I got the dictionary operator question mark colon. It simply has an extremely low precedence. Let's test this anyway, just one more time, as it were. It's not working, including the size type. This should work. Yep. So the precedence is so low that you can just, only the equal sign is lower. So it's going to do this one first, and then the whole of that is assigned to previous offset. I think you should definitely start with C++. Forget about C#. You'll never use C#. C# is a shitty language. If C++ is too difficult for you, I would still not use C#. Go pick some other language. Thank you, Mr. Smith. Or was it to someone pasting a... I'm hoping you were talking about my stream. Okay, so you have here the previous member offset, and then you can do the same thing for the size. Okay, how to change to this is... What? Oh no, what is this? Why this thing does not have a memory index? Huh? Doesn't make any sense whatsoever. Oh, right. Yeah, I'm getting it. Oh, yeah. Well, that sucks. Oh, yeah. Hmm. Hmm. Maybe I put too much work into inside a layer, a line and resize. It's not really in. Yeah, I don't know. I want to change everything back. We still have to do this calculation here. Or it's more like something that goes before align and resize, I guess. I want to undo everything. Kind of strange that it doesn't work, isn't it? Oh no, I removed the assert. Assert is now commented out. Okay, git add -p. offset. I'm going to need it in eventually, right? So let's add the offset indeed. Not even sure this worked yet, but work in progress, right? Okay, so let me think. I do not want to add it to a line and resize. The job of that is, yeah, just what it does. Although, you know, the main reason is that because it got blocked by that last change. Not that. And in, nobody knows where. Here, I'm applying a line and resize on the element of an array. And the reason I'm doing that is because whatever the element is, it needs a certain alignment. And offset, no, it needs certain alignment and size, yeah, which is returned by element layout. So there is absolutely no offset inside here. Cannot have an offset per element for a whole array. You can only talk about the offset of a single of a whole array, not of the array elements, of the first element, but not per element. It's impossible. This thing does anything with offsets. Yeah, yeah. Okay, so basically this implements a line and resize for array specialization in terms of itself. And if I do not do anything with offsets, then no offsets go in, no offsets go out here, nor anywhere else. But this thing, what I have here, needs a certain offset, which depends on the member index. So I'm going to need a different type then. Maybe offset align and resize. Get what I mean? Definitely. Yeah, that's what I'm going to need. So we make a new class, and this is now called offset alignment and resize. And that one can have these two things split. And originally this was align and resize, so I just add it back. What's calling this member layouts int member index. I think I used int, right? Yeah, using int here as well. So this used to be implemented as a member layouts member index. So I can still do that. So this should still compile now. Just inserted a new class, but for the rest it's the same thing. Okay, it's not a template. How does that work again? I say I seldom, if ever, yeah, I did it, but seldom. You need a template parameter. This is a template itself. I don't know. Let's Google it. Template parameter example. Well, this is an example. Apparently, template class. Is using class instead of type name, but for the rest, simple enough. Template. That takes int. Actually, I think that member index goes into here. So indeed, that's more like this example where they use a uint and then pass it. The version goes inside of that. So yeah, that is the way it is done. Someone is making noise, and that someone is my brother. Ja, oké. Die kan ik pas zondag krijgen. Okay. Yeah, my keyboard keeps dropping off. So annoying. Put this on it. Class, suspected class or type name. No, it did not work. Did not work. It is annoying. Oh, I have to put the type name there. Maybe I should use class here. I don't think it makes any difference, but my memory layout is always a class or a struct. Let's use class for a difference. For a change, I mean. It compiled. Okay, but now I have to fix this thing. Because we need padding in front of it, right? So I'm going to add padding. Depends on something. Maybe it should name it padding align and resign. Nah, offset is good. Okay, the padding is going to depend on, well, let's define it first. It is a template. Template with some arguments, don't know yet what. Call the struct, because I'm not doing anything about private stuff. It's access control. I just want it to be a struct. Padding. Now the padding exists of character array called padding. I don't know, did I do that before here somewhere? Yeah, there, padding. Align is align padding. Oh, already have it. I have a padding. This one can also be 0, so it's maybe better to use the one that I already have, align padding. So we put align padding in front of this. Yeah, I have no clue. This thing takes padding and alignment, okay. padding and alignment. Padding here and then alignment there. How are we going to calculate that? I think these things have constructors, non-default constructors, and this thing is, I don't care about the constructor of this thing, so this can do using this. I think just use the constructor of the second base class. Dude, just Google it. I don't know anything about VS. I just use what I've been. I'm a how do you call it? Dinosaur. You know. I'm just using what I'm always been using for decades and decades. And normally I really I'm not trying to hold on to things. If there is an improvement, I really want to use it, and I have tried IDEs several times, but they suck with what I already know. So, for example, for the longest time, IDEs on did not support Vim as editor. You had to use some kind of Windows-like editor. That was definite no for me. And I think now there are IDEs that support Vim, but I think even that new Vim was created especially so it was possible to use it as a plugin. That was one of the main requirements for new Vim. So it could finally be integrated into IDEs and stuff. But I don't need it. I don't need it. I don't have any. My production is not going up if I switch from my system to an IDE. It is going down, 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 and it's only going up then again when I get used to this new IDE. But I'm too old. It will take me years and years of using the IDE before I get to the same production level that I am now, the speed that I can work with this. And by that time, I can stop programming because I'm too old to program in the first place. So I'm not going to change to an IDE. But if you're young, then by all means Google it and figure out what is the best IDE for you and then start to learn that. And it's going to take a while before you can use it. So it is an investment, and the investment is pretty huge. So yes, it's a good thing to make sure that you learn the right thing here. And ask around, but I don't know the answer about it. Forward to it. I think that the alignment that I pass here should just simply be equal to the alignment that I pass here. Which is a rather involved calculation done by aligning the size. Therefore, I should maybe make that a calculation that is done in a different thing, maybe in a function, a template function. The alignment is the enforced alignment, which is calculated from, okay, it's just a standard GCD of the required alignment and the layout size. What the required alignment is the layout alignment, so it's not that involved. That's the alignment that's going to use. Where layout is whatever I'm passing here to align and resize. So I could do that. Alignment goes last, I think. So this is and where layout is this thing. Yeah, there's just the same formula as align and resize uses. If you pass that as layout. And the padding then is really a formula. I'm going to use a template function for that, I think. So that is then how we shall call this offset. It's a bit short, isn't it? No, let's call it required padding. And yeah, it's going to be a const expression function, otherwise you cannot use the result as a template parameter. So we're just going to pass all the arguments as template arguments. And then we can calculate this from member layouts, which gives us the layouts of all the members and the current member index. Okay, let me put this on 2 different lines. Online padding. Now it looks like it still doesn't fit, but it fits if I switch to this, right? Where was I coding here? For this one? Yeah. What? Oh, there. Yeah. Doesn't look too bad. Okay. Then I have to implement that function. Required padding. To align padding, it starts with a size type for the padding. I want something that returns a size type. And it is a template function which takes as arguments again a template int and just the last two arguments of this template. Yep. Now we can, it must be a const expression function. which implies that it is in line, by the way. I could make it static as well. I don't think that's really needed here. So now I need the offset of the previous member. I'm going to make that static const expressions. Although static const expressions is more for a member thing in the struct. This is const expression function. I think I can just use local variables here, as if. So get the size type previous offset, previous member offset. And then we could do member index -1. Offset, correct. Now, what if member index is 0? There is no previous member before that. So when is member index 0? Member index is 0 when we're trying to get the offset and offset align and resize of the first member. Then member index 0. In that case, the align padding should just be 0. I don't want any align padding in front of the first member. So the only requirement that I have is that this should return 0. Yeah, so I can do if const expression member index equals 0, then return 0. Now, if I would leave it like this, you would think we never get here, but this is not true because this is being compiled. And now it's going to compile return 0 when member index equals 0, and it's going to compile the rest always. And that means that we would instantiate member layouts for -1 still. And if I do not want that, then I have to use an else here. Now if member index equals 0, it's going to compile return 0, but it's not going to compile this. So now we only get here for member index larger than 0 because it's never negative. And I could do less than or equal 0, but that hints that it could be negative, and that's then super confusing. You would say I could make it an unsigned int to tell that it's never negative, but I have the, what's the word, habit, it's different. Private standard, convention, that's the word. Yeah, well, it's my own convention saying that I don't use unsigned ints unless it's absolutely necessary. I definitely do not use unsigned for as only reason that the value will never be negative. I can see that it will not be negative from the fact that it is a member index. I mean, I don't have negative indexes. An int is an int. It's not like if you make it unsigned that you switch to n, if you want to know what I mean. So the natural numbers. We don't even have fat n's and z's here. Incredible. Or is it? Is n here? No. This should be written with a thick first thing, and I don't do that. Really, I want to show the actual thing that should be used. I'm going to call it math n. Wikipedia doesn't do it, and I give up. Yeah, there it is. Oh, it's like that. Sorry. So this means all the positive integers. Or the non-negative integers. So let's say they start at 0, 0, 1, 2, 3, etc. And then you have the integers are denoted with z. So that looks like a Z with a thick thing in it. And what I wanted to say is that if you have C++ and you use an unsigned int, you do not get Z. Sorry, you do not get N, the non-negative integer. What you get is a field, a finite field with, so can denote as Galois field with size 2 to the power 32. Well, yeah. So modulo, field modulo 2 to the power 32. So that's not what you intend. So if for the only time that for the mathematical integers, there's infinite of them, right? I mean, it goes on and on and on and on, far beyond 2 to the power 32. So the only way that it matters that you have only 32 bits to store this is when you have to deal with large numbers, and then I don't mean large is positive, but also negative. So just the absolute value is large. Then it comes into play that you have only 32 bits. And so whenever you're using an integer that is not that large, so that the size of the integer is not going to get into your way, it doesn't matter if you have 32 bits or 64 bits, it's going to fit anyway. Then we're talking about small integers, and these integers are definitely small. Member index is 0 or 1 or 2 or 3, you know, something about that order. So it's very close to 0. And therefore it is, in my opinion, very close to -1. And it's very, very far away from 2 to the power 32. You get what I mean? So therefore it's just better to use int, because then you have something that is an integer. And it will not go wrong when accidentally you subtract 1 from 0 and then end up with 2 to the power 32. Not with -1, you end up with a very large number. That's way more confusing and gives rise to way more nasty bugs and errors than when you just indeed get -1. I don't know, it's based on loads and loads of experience. It's just better not to use unsigned if you have small integers. That was a long explanation of why I'm using int here, even though it can never be negative. But then I still want to use equals 0 here, otherwise I would hint that it can be negative. So in this case, it will be larger than 0, and in that case, we can subtract 1, and then we still have a positive integer, still have a positive index, I mean. And the same, of course, for the size. The size of the previous member is then that. And I want to have the current offset, no, the required offset. Yep. And now we are ready to calculate the padding. The padding should be, sorry, we have to return, yeah, the required offset. Sorry, I need, yeah, I can do it with this. This offset already incorporates everything, which is depending on the required alignment and the previous member. But that work was already done. So if you have an offset in here, then I might as well use it instead of starting over from the alignment requirement. It's NeoVim, yes. So this is correct, right? The padding is required offset minus the previous offset minus the previous size. I'll make an ASCII drawing. So the previous element is sits here. And this is then the previous element size. And we want to have required offset. And this is our new member. And then here I have the required padding. I'll just have to make it like that. Yep, so this padding here is equal to this value minus that value, which is this distance, minus the previous size, which is this distance. So then you end up at this value. And that's what I'm returning here. However, this could go wrong for unknown reasons. I have to eat, I guess. Yeah, my life should look a bit more regular. I should just, you know, bam, stop the stream. And I think I'm going to. I just want to make sure that the required offset, that this not becomes negative. Then there's a really bad error going on. So I'm going to add a, oh, this is a const expression function. So it must be a static assert. It will be checked during compile time. Required offset must be larger than or equal to the previous offset plus previous size. Otherwise, it's not going to work. This should never fire. It's kind of impossible because we get all the values from other computed values. So, but it's not something that the user can do wrong. I'm just being paranoid, and then I add this comment, usually paranoia check. That kind of means that I don't expect it to ever fail, and if it fails, I don't know what the error would be. Then there's just a horrible bug in the code. It just needs my attention. Right. So now I have the required padding function, and I call that here. And I think now it should work. If it compiles, I guess I can just go eat because it works again. That means that as soon as it compiles, I can go eat. Okay. That doesn't compile. Come on, why not? Non-constant condition. I think these things are non-const. Okay, yeah. I guess that making it a const expression is that means that if you call this and it can be compiled and executed during compilation, then that is going to happen. But this function can also be called at runtime. So it has to compile this also for runtime. And then this static assert is not a static assert. Now C++ 20 added another possibility, and that is called const eval. And that keyword guarantees that it has to be and will be always done during compilation. Now I'm not saying that this is going to get rid of the static assert, but it might, because now it's just really completely 100% all the time compile time thing. So I just want to try that out. No, it's still not working. Well, I would call that a bug in the compiler, but okay. I guess it wants us to explicitly state that these are const expressions. Or maybe it would work just making them const like this, just const, but might as well call them const expressions. Now definitely should work. If this compiles, and I wouldn't know why not. C++, C#, dude. Then at least ask Rust or C++. Required from struct GLSL offset blah 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 blah. Offset is not a member of. I fear this would happen. So we have a layout that is derived directly from a basic type layout, which did not have an offset. Well, okay, at least now we can start to figure out why that is happening. I mean, why we're getting a basic type layout in the first place. This is required from, you see, constival, required padding. This is required from here. Required from here. Let me look at both. Yeah, of course it is required padding is being called here. So apparently this member layout has a basic type layout as template parameter, which I hoped would not happen. That is required from here. Member 1 offset align and resize. Yeah, that's what instantiates it. And then layout is the wrong thing, it says. I think I'm going to eat because it's even if it takes only half an hour to get it to compile now. You know, I want to, like I said, I need more to eat more regularly and not continue streaming because I'm streaming with 50 people watching. So sorry guys, I'll continue later.